All right, what's today's date? May 6th? All right, May 6th, there we go. This week in Cassandra, on Planet Cassandra. Today we've got me, of course, because I'm here sometimes. We have Patrick McFadden, Luke Tillman, and our guest this week is Russ Bradbury from Simple Reach. He's going to be talking to us about some advanced architecture patterns that they've implemented over at Simple Reach, some of which may be a little confusing at first and non-obvious, but Russell kind of give us the lowdown on what they've been doing and why it works and why it's awesome. So before we get going on that, let's talk a little bit about some of the stuff that's been in the news, if you will. There was an interesting post this week on visualizing data with Zipkin by Mick over at The Last Pickle. I'm pretty excited about this because I just really like Zipkin a lot, and yeah, I'm pretty pumped to see this. Have you guys taken a look at this? Oh, a lot of echo. That sucks.
Well, the Zipkin is amazing, I think, because it's opening up a whole new realm of monitoring for us, of course, from the Dapper paper at Google, and a lot of cool technology comes out of some really cool paper from some big company that has this problem. So the Zipkin stuff, of course, came from Twitter. Am I right? Yeah, and I was just talking to a team at Uber yesterday. They're pretty much heavily reliant to the point where they don't know how they could do what they do without it. And I think that kind of sums it up.
Yeah, if you're working and you've got a request going through multiple systems, if it's 4 or 40, I don't know how I don't know how you could go back from using a tool like Zipkin, where you can look at an individual trace and see all of the servers where time was spent and just narrow things down and be like, oh, it's the problem is obviously here. Like, I have this giant span of time, and we can just figure that out.
There are tools that were out there that are doing this, the APM stuff, the application performance management, and they just didn't give you the right, so just in a nutshell, what Zipkin does is it sets up this like trace ID as things go through a distributed system. So from the request all the way down the chain through microservices, and as we do more microservices and spread these things out, all those requests have to go from one point to another point to another point. So what happens whenever from the endpoint you say, I made a request and I got it back after 500 milliseconds. Why? Well, unless you've got a lot of debug code and you feel like going through a lot of logs, you're never going to find it. And that's what Zipkin's promise is, or at least the Dapper paper, was that with this transaction ID, it will take those traces each point and say, okay, this is how long it took for each place, re-roll it back to you, and then you can say, oh, okay, I had some middle service call that was really long and everything else was super fast. Let's figure out what that is. So it just goes in line with this. Troubleshooting distributed system problems are hard, but this is definitely the bat belt to make that easier.
Yeah, Patrick, we were talking about that. You were at a software architecture conference a couple weeks ago, and you said all the talk there was all about microservices because that's the super hot thing. Everybody's been doing it for about a year now. That's been the super hot thing, and I can't imagine building a system like that, building a microservices architecture right now and not having a tool like this to be able to have insight into, what it is that's causing problems. It's like you're basically like operating blind if you don't have something like this to tell you what's going on. So, I think you'll see this more and more popular, as those microservices architectures continue.
Yeah, Russ, I know that you guys are big into microservices over at Simple Reach, right?
Yeah, we have like a full suite of reactive services that we actually, before Zipkin came out, we kind of hand-rolled a similar thing where, as the events come in, every so often we would tag an event with tracer, and then that would be like sending, each time it went down the line, it would send something to statsd. This Zipkin is really cool. It's just really an interesting piece of software, and I'm excited to try it out.
Yeah,
there were changes that were made to Cassandra, right, John? I mean, there had to be some changes that make that work.
Yeah, so that's So funny you bring that up. I'm actually going to be talking about that up in Vancouver at the Apache conference that's happening next week. And one of the part of my deck here is in 3.4. It was made so that tracing could be pluggable. So previously, like for pretty much everybody in the world who's not running 3.4, when you want to do tracing with Cassandra, you're just limited to whatever shows up in the tracing table, and there's really no context. You have no idea like who made the request, what happened, like what was going on. So with pluggable tracing, and there's another article by Mick that came out like somewhere around last year. It kind of goes into like, okay, like for using some of the new stuff that was added to the CQL protocol, and with 3.4 we can make it so that we can pass that trace ID that you were talking about. We can pass that along into Cassandra, and then it'll report all that tracing data. So like this request came in over here from whatever user, and all these microservices were hit, blah, 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 blah. And then Cassandra was hit. You can even see the granular level of like, oh, it took this amount of time to read the SS table data. And so you have like a really solid understanding. And then using a tool like the new SS table dump or the old SS table to JSON, you can take a look at the actual data that's in the SS tables and figure out what happened there. So it's very, very cool. I think that this is going to be one of those things that really ramps up in popularity, because if I was building a system right now, I could not imagine doing it without Zipkin. Like you just bake it in from the start, and it's just going to save you hundreds of hours of debug time. So I'm excited.
Should be excited.
Yeah. And hey, Luke, maybe I think you said that you were doing some work right now with refactoring Killer Video.
Right.
Maybe we should get Zipkin in there.
I've been thinking that for a while. Yeah, I was gonna see what the state of it is as far as various programming languages I can plug it in with, because right now Killer Video that's getting refactored is the web servers in Node, so I'm guessing they probably got JavaScript support, because that's anything and everything is being written in JavaScript these days. Now whether or not they have .NET support, that's a whole other thing, but we'll see. But yeah, definitely want to check that out.
Well, the interesting part about Zipkin is that, and Dapper, at least with the original paper, was the data is written at a sampled rate to a local file. So as long as there's like an understood file format, you're not looking at a situation where it's like, oh, I have to debug a bunch of like Java classes and like write out like this like magic thing. It should be pretty straightforward to write that debug information.
Yep.
Even if that library isn't there for you.
Yep.
Cool. Well, the next thing I know that we wanted to talk about was the MVP nominations are open, and this is always a fun time, right? Because we get to acknowledge the people in the community that have done a lot of work to help promote, to help other people how to use Cassandra and teach things, and have built cool projects. And Russ, you've been an MVP what, like 1,000 years running now, something like that?
Since the beginning, actually.
Yeah. I remember Russ when. Oh, go ahead.
I was going to say I should stress like what makes why is Russ an MVP forever, and we have the nomination form up there, and this is probably a good time to pitch this, but and it's in the show notes. You can look at that, but the nomination is just that. It is a nomination. It's not me and John sitting there drinking and talking about who we think is cool. It is from the community. Even though we do that does happen.
It's gotta happen.
That's gotta happen, right? But what we do is we take this form that we've linked, and that form is for you in the community who says, hey, I know someone who's doing some really cool stuff in the Cassandra community, and then we have some criteria. So it's not just, hey, they're cool. We actually are looking for people that are doing things like, if you think about contributing to a community as a whole, so blog posts, presentations, like doing meetups, contributing code to Cassandra. There's a few criteria. If you know someone who meets that criteria, then by all means nominate them, because we want to make sure they're recognized. And if you look at our current MVPs, these really, I mean, they really do have the M and the V going on, because they're just, I mean, Russ, you guys talk all the time about stuff that you're doing, like today, but some of the others that have been in there for a long time, same story, and it really makes the community better.
Yep, that's good stuff. I think, I mean, this is like what we're going to talk about today is kind of the perfect example. You guys have been. I think we talked about, there's two things that you guys have going on right now that I think are, really, really interesting. You're one of the only, teams running on EBS, and I know that you guys have just done a bunch of work spinning up what you've been calling a coordinator-only tier, which is really interesting because I talked with you guys kind of separately about this, and we threw some numbers around, and I was kind of blown away by some of the results that you guys got. And this stuff's really, really interesting. I don't know, can you give us a little background on the coordinator tier?
Yeah, so originally we were running, our cluster was running the standard, Cassandra and AWS best practices, which is running Cassandra on the I2 instances, which have the ephemeral SSD volumes and have just an extremely high amount of IOPS, a high amount of throughput. And we were hitting a point where our cluster was getting to about the time where we need to start adding nodes. And what we ended up doing was starting an upgrade, and that upgrade ended up catching a pretty nasty bug. So to work around that bug, we decided to put what we call the coordinator-only tier, and that's simply just starting up a Cassandra node with join ring equals false. So it takes over all the coordinator functions and allowed us to kind of do the upgrade because the bug was within the coordinator functions, and we just kept the coordinator tier on a lower version of Cassandra that didn't have it. But what we ended up realizing and noticing, and was that it dramatically reduced the amount of CPU load on the actual cluster. So we had a 48 node cluster. We added 6 coordinator nodes, and these nodes were running on cheaper hardware because they didn't need the high throughput SSD volumes. And we saw about, our average load was sitting around 8 on these 8-core machines, and went down to around 2. 2 to 3, and we were just kind of blown away by just this small amount of cost in terms of the hardware, leading to a dramatic decrease in the amount of utilization of the cluster.
Yeah.
And a big shout out goes to Rick Branson for that, because I think he was one of the initial ones that came up with the idea, and he actually helped me through it a little bit with some of the JVM tuning, because it's a coordinator only node, you can actually tune the JVM for coordinator specific functions, which is like having like very large heap where you can create a lot of small objects in the memory space. So and then you can also tune your data nodes for data functions like mem tables and I/O throughput. So it really gives you a little bit versatility there.
Interesting. One of the
I'm curious, did you take a hit in latency at all with your ops, because now you're hopping through this coordinator tier instead of maybe the driver being smart and going directly to nodes that own a given piece of data?
No, not really, because like I said, the nodes were kind of hitting their peak load. We actually didn't see much of a difference. The apps didn't even notice it.
Interesting. One thing I'd be very curious to see is if so I've kind of dealt with some going completely against like the common pattern that you would expect. I remember when I was deploying Titan in production, people would, the advice was, well, co-locate Titan with Cassandra. I did the exact opposite and found that I got way better performance. I'd be interested to see what the difference would be if you were to co-locate the coordinator tier with your application server and only talk to your local coordinator. And the thing that's interesting about that is because then you avoid the extra network transfer, kind of in the example that Luke is talking about. Like you're just going over shared memory at that point. So it's kind of like, whatever, maybe it's not that big of a deal, and it doesn't involve spinning up new servers. Be interesting to try.
Yeah, if you had a small number of app servers, I think that would be, really doable and preferred. We have like hundreds of app servers, so having hundreds of coordinators and managing that would be kind of like, I think, a maintenance, like a management nightmare. You know, especially like if one coordinator kind of goes down, then you have to rewrite. But and you have to the way that we keep the apps from connecting to the main cluster through the drivers is to use a whitelist round robin policy rather than your standard DC aware round robin.
Yep, that's pretty interesting. I would love to dig in, because when I hear stuff like that, I'm like, oh, that's counterintuitive. Like, what is the root cause of this? I think it'd be fun to you know, dig into that a lot more and understand exactly what's going on. Like, where's that time spent? Like, why would it have such a dramatic decrease? You know, what would happen if you put the coordinator tier on the same server as the data? So you would actually run, what if you ran 2 JVMs, one just for the data and one for the coordinator? Like, would that have an impact? So those are really interesting things, and I love to see people like just trying stuff that doesn't seem obvious and may even seem like a bad idea. You know, if you haven't tried something like that before, you know, distributed systems are one of those things that your intuition is frequently wrong, and you got to try stuff like this to figure it out. So,
Russ, are you guys planning on keeping the coordinator tier? It sounds like it was kind of like a temporary thing that you tried, and maybe now you're thinking it should stick around.
Yeah, it was originally just a temporary, like a workaround, and now, just because of the dramatic improvement in performance that we've seen, we're definitely going to be keeping it around.
I'm curious. Were you using token-aware routing from a client beforehand too?
So yeah, we were using a token-aware routing.
So it wasn't even really doing any coordination. It was just dealing with the requests.
Yeah, I suppose. We also, it's important to note, we also do cross-partition batching. So it's probably the batching. So.
Oh, okay. That's a very important thing. Yeah, because the coordinator is responsible for maintaining the state of that batch until it's finished, and so I'm sure that had a lot to do with it. And that's a very interesting detail. Yeah.
Another Cassandra anti-pattern
that makes sense
that we
now.
embrace.
Yes. No. Now I actually understand now why the coordinator node makes sense, because that's a hard load to manage. One of the reasons I don't recommend using batches. But it's an interesting way to get around it.
Yep. The other thing that you guys are doing that I thought was pretty cool, that I've only really heard of, you know, the guys at CrowdStrike doing, was running everything on EBS. Did you notice a performance difference from switching to EBS?
No, and you know, I like to say, like, running EBS and this stuff, and coordinator nodes and all this stuff, this is all like use case specific. You have to know your business, know your use case in order to make these decisions. Now, the reason why EBS volumes, and we're running the new ST1 EBS volumes, which are high throughput, low IOPS, so they only have 500 IOPS, but they can do 500 megs a second throughput. But the reason why we get such good, and I won't say performance, but because the performance is the same or probably a little less than the ephemerals, it's the cost savings, the dramatic cost savings. And the reason why it works for us is because we're 95% writes, and as you know, writes are sequential to disk, and we're 5% reads. And because we're an analytics company, we track time series data. That 5% reads is like the 2% of the data, the most recent 2% of the data, and that means that it's in the page cache 95% of the time. And so because it's in the page cache most of the time, we don't even have to hit the disks. So we can use these super cheap EBS volumes and store a lot of data on them, because we don't need to read the data. And when we do need to read the data, we want high throughput because we're typically doing Spark jobs against it. So having that high throughput, 1 megabyte read ahead, 500 megs a second, actually helps the Spark jobs perform better.
Interesting. I appreciate not just the, hey, we use EBS, like whatever, but the reason behind it, because sometimes people will see like, oh, they use EBS, we might as well just do it too, and not even think about that use case. Like to me, that's the most important thing, is understanding all the, exactly what you said, the business case behind it, like understanding how much of your data is in page cache. It's so important.
Yeah.
So
many horrible Hadoop projects got started on that. Oh, Google uses Hadoop, right? Or Yahoo uses Hadoop. We'll use it, and it'll be magical.
Yeah, it's like, oh yeah, Facebook built an entire business on sharding MySQL, and you're just like,
that's exactly the way we're going to do this.
So many times, like how many times do you hear that? It's like,
yeah, you hear a great technology, and you're like, well, we want that. Let's do that technology.
Yeah, great.
Whoops.
Yeah. So cool. Well, I know, Russ, I know you have like a hard stop coming up, so I don't want to screw up your day. I appreciate you coming on. I mean, dude, it's so cool to talk about this stuff.
Thank you.
And this is why you're definitely in that MVP category. Like, this is really, really cool stuff.
Thanks.
Anything you guys want to say before we sign off?
So we're always looking for the best talent. If you have a passion for analytics, Cassandra, and just high volumes of data, reach out to Russ at SimpleReach or Eric at SimpleReach, and we're always looking for people.
Cool. Luke, anything?
I got nothing. Get your nominations in for Cassandra MVPs.
Yes. And put your CFP in for Summit.
CFP
yeah.
for Summit, absolutely.
Yes.
And John, I think next week we should have a little how to do an awesome CFP. Let's do that next week.
Yeah.
So stay tuned. Come if you love this episode, next week will be amazing. So Russ, you're going to be there, right?
my solution to that is I usually just ask you for help with my CFP.
Well, it was funny because I was just thinking about writing a blog post on what would be a great CFP, and a great CFP is not going to talk about cool stuff I did. No, that's not
lots of eye shifting.
Yeah, it's awesome. Trust me. Actually, we saw that in a CFP one year. You will not believe what I'm going to talk about. Trust me. No, I will not.
I won't believe it. You're right.
And you know what's funny is the person who sent that probably is listening right now.
Yep.
Mm-hmm.
Cool. All right, guys. I think we can sign it off then. Thanks, Russ.